PDF दिख रहा है?
हाँ सर।
हाँ सर।
ओके, सो यू हैव टू गिव मी फीडबैक, दिख रहा है नहीं दिख रहा है, आवाज आ रहा है नहीं आ रहा है, बिकॉज आई डोंट नो व्हाट इज हैपनिंग, नेटवर्क का इश्यू होते रहता है, राइट? सो एग्जांपल 7.13 सॉल्व एग्जांपल ये अगेन, fugacity of component 1 in binary liquid mixture of components 1 and 2 at 298 Kelvin and 20 bar is given by this equation. Fi bar is equal to 50x1 minus 80x1 square plus 40x1 cube. Now we need to, where F1 bar is in bar, F1 bar is in bar, and x1 is mole fraction of component I. Component 1, sorry. So we have to determine the fugacity of component 1, F1 of pure component 1, and fugacity coefficient F1, should be F1 bar, I think. Let me see the book. Fugacity coefficient is 5.1, not F1. ये थोड़ा गड़बड़ है, बुक में बराबर दिया है, ये PDF में थोड़ा है गड़बड़. Then we have to find out Henry's law constant K1 and activity coefficient gamma 1. PDF में बराबर नहीं, थोड़ा some differences. So you have the book at home, right? सबके पास बुक है?
नहीं सर, PDF से ही कर रहे हैं।
PDF से कर रहे हैं? क्यों भाई? बता रहा हूँ आपको, PDF में मिस्टेक्स है, अभी बताया मैंने आपको, 3-4 समझ में नहीं आएगा, फिर आप सोचेंगे जीवन क्या है. क्या बोल रहे हैं
सर? हम लोग लॉकडाउन में घर आए थे तो बुक नहीं साथ लेके.
अरे लॉकडाउन में नहीं, सेमेस्टर चालू हुआ था दिसंबर में. कब चालू हुआ सेमेस्टर? दिसंबर में. थर्मो 1 के लिए कौन सा बुक यूज किया आपने? कौन सा बुक यूज किया था?
सर वो वही पर वो स्मिथ का लिया था, पर वो घर नहीं लेके आए थे.
ठीक है, ओके. So now if you know, if you're going to use PDF, there are some differences. It's not exactly as per the book. मेरे पास बुक भी है, हार्ड कॉपी और PDF दोनों है. That's why I can compare the two and tell you what is the difference. ये F1 बराबर है, आप घर जाके देखते भी नहीं हो, तो आपको कभी याद नहीं रहेगा. आप एग्जाम के टाइम पे खोलोगे और बाद में बोलोगे अरे ये क्या हो गया, तो गड़बड़ हो गई, सर ने कुछ और बोला था, यहाँ कुछ और है, राइट? Fugacity coefficient is 5.1, not F1. Activity coefficient here is gamma 1, not G1. Okay, so when the mole fraction approaches unity, that means pure solvent, the fugacity of a component in solution becomes equal to fugacity of pure component. ये हमने देखा था, right? That is our definition of fugacity. So F1 is equal to F1 bar when x1 equal to 1. ठीक है, तो F1 equal to F1 bar, this one, when x1 equal to 1. So x1 equal to 1 डाला तो what you get is F1 for pure component. मोल फ्रैक्शन इक्वल टू 1 हो गया तो प्योर कंपोनेंट फिगस्टी मिल जाएगा हमारे को. दैट्स व्हाट ही हैज डन. सब्स्टिट्यूट x1 इक्वल टू 1, व्हाट यू गेट इज F1 इक्वल टू 10 बार. ठीक है, समझ में आया? सिंपल सब्स्टिट्यूशन है. ओके, नेक्स्ट वन इज फिगसिटी कोफिशिएंट 5.1 इज इक्वल टू F1 अपॉन P. बाय डेफिनेशन फिगसिटी कोफिशिएंट इज फिगसिटी डिवाइड बाय प्रेशर. तो फिगसिटी 10 है, प्रेशर 20 है, सो फिगसिटी कोफिशिएंट इज 0.5 and this is dimensionless. There are no units because F1 का भी units बाहर है, P का भी units बाहर है, तो 5.1 will be dimensionless. Okay, any doubts on this B part? Next is Henry's law constant. K1 is by definition limit of F1 bar by x1 as x1 tends to 0. Infinite dilution के लिए define किया हमने Henry's law constant. So x1 has to be 0. So if we take F1 bar by x1, ये जो F1 बार इसको x1 से डिवाइड किया हमने, तो हमको मिल जाएगा 50 minus 80 x1 plus 40 x1 square divided by x1, this whole expression on the right hand side, right? And take the limit as x1 tends to 0, right? तो ये टर्म 0 हो जाएगा, ये टर्म 0 हो जाएगा, what you get is 50 बार K1. Any doubts, questions? Simple application of definitions है और कुछ नहीं है. Okay, the D part is activity coefficient gamma 1 is equal to F1 bar by X1 F1. This is by definition again gamma 1 क्या होता है, right? So what you know, F1 bar is 50x1 minus 80x1 square plus 40x1 cube, and F1 is 10 हमने निकाला था यहाँ पर, and x1, right? So if we divide each term by 10x1, what you get is 5 minus 8x1 plus 4x1 square. So gamma 1 is a function of composition. Depending on x1, mole fraction of component 1, gamma 1 will change. ठीक है, any questions, doubts? Simple problem है. This had come in final exam of November 2017. 3 साल पहले exactly ऐसे ही आया था problem. Same to same, no change. ठीक है, any questions? Yes, no, कुछ नहीं.
No, sir.
No questions. ठीक है. So next we'll see example 7.19. 7.19 of Narayanan. The theory हमने already किया है. I'm just taking the examples now and problems. Okay. ये हमने देखा था, I think कल ही देखा था हमने ना. 7.19, I think we have seen this yesterday. Vessel is divided into 2 compartments. Nitrogen 100 moles, oxygen 100 moles. तो एक ही देखा था कल हमने, right? We have seen this yesterday. Okay. Next is 7.21. Okay. So this is a little difficult, but not very difficult. Okay, so here a container is divided into 2 compartments. One contains 3 moles hydrogen at 298 Kelvin and 1 bar pressure, and the other contains 1 mole nitrogen at 298 Kelvin and 3 bar. जो हमने पहला क्वेश्चन किया था 7.13, इसमें प्रेशर सेम था दोनों का, राइट? जो हमने पहला देखा था 7.13. Sorry, 19. Yeah, 7.19 जो कल हमने देखा था, there were 2 compartments again. One contains 100 moles of oxygen at 298 Kelvin and 1 bar, and the other contains 100 moles of oxygen at same conditions. So temperature and pressure were the same. So this was easier to solve. Now what is happening is pressure is not the same on both the sides. Right? One contains 3 moles hydrogen at 298 Kelvin and 1 bar, and the other contains 1 mole nitrogen at 298 Kelvin and 3 bar. Temperature is same, but pressure is not the same. So when we remove the barrier, the pressure will change. Right? It will be somewhere between 1 and 3 bar. We have to find out the pressure क्या होगा mixing के बाद, and then calculate. To calculate the free energy of mixing when the partition is removed. Right? ठीक है, समझ में आया क्वेश्चन?
हाँ, sir.
Okay. So in this case, what will happen is when you mix when you remove the barrier, there are two compartments. एक में 1 bar pressure है, दूसरे में 3 bar pressure है. So when you remove the barrier, they will mix with each other, right? Hydrogen and nitrogen will mix with each other, and the pressure will be somewhere between 1 bar and 3 bar. So we have to find out that pressure. So assume the gas behave ideally. Then the volume occupied by hydrogen is V is equal to nRT by P, right? बराबर. Volume is equal to
Yes, sir.
nRT by P. Number of moles is n. So 3 डाला है, n is equal to 3 डाला है, और pressure equal to 1 bar डाला है. So it is 3 RT. ठीक है. So volume occupied by hydrogen is nothing but nR 3 nRT by P, where n is equal to 3, in this case 3 moles, and P is equal to 1 bar, so it becomes 3 RT. Similarly, volume occupied by nitrogen is nRT by P. N is again 1 mole, here 1 mole, and pressure is 3 bar. Right? So you substitute n or P का value, you get RT by P. समझ में आया volume of hydrogen and nitrogen? So total volume will be 3 RT plus RT by 3. That means total is 10 RT by 3. So total volume is this much. Okay. So now we need to find the final pressure. Final pressure attained by the mixture is P is equal to nRT by V, right? Pressure PV equal to nRT लिया हमने, तो P is equal to nRT by V. Now n is what? 3 plus 1, 4 moles of total moles, right? Because we are assuming both are ideal gases. So total moles is 3 plus 1, 4 RT, and total volume is 10 by 3 RT, right? ये हमने निकाला total volume. Volume is not changing; it is a fixed container. So 10 by 3 RT. So it is pressure is equal to 1.2 bar. So it is between 1 bar and 3 bar. ठीक है? Any questions on how we got the pressure?
No, sir.
Okay. Now what we do is, because now what is happening is, this gas hydrogen is at 1 bar, and this gas nitrogen is at 3 bar, and the final pressure is 1.2 bar, right? So we have to define a path how it is going from 1 bar to 1.2 bar for hydrogen, right? And from 3 bar to 1.2 bar for nitrogen. That's a transition, right? That's a change which is taking place. So we assume that the process is taking place in 2 steps. It cannot be 1 step. In the first step, the individual gases are separately brought to the final pressure. That means we assume that we are bringing hydrogen from 1 bar to 1.2 bar, and nitrogen separately from 3 bar to 1.2 bar. At constant temperature. Temperature same here, right? Temperature दोनों का same है, 298, 298. Temperature is not going to change. And the second, the gases are mixed at constant pressure and temperature. जैसे हमने पहले किया था, 100 moles oxygen, 100 moles nitrogen at same pressure था. तो mixing at same pressure हो गया. So now the same thing we are doing now. We are saying we'll bring hydrogen from 1 bar to 1.2 bar and see what is the change. This energy change कितना होता है उसका, pressure change का. Similarly, क्या है, नाइट्रोजन फ्रॉम 3 बार टू 1.2 बार किया चेंज, तो कितना फ्री एनर्जी चेंज होगा, एंड देन मिक्सिंग किया तो कितना फ्री एनर्जी चेंज होगा. सो इट्स गोइंग 2 स्टेप प्रोसेस. वन इज चेंज ऑफ प्रेशर एंड सेकंड इज मिक्सिंग. ठीक है. फॉर द फर्स्ट स्टेप, चेंज इन फ्री एनर्जी इज ड्यू टू चेंज इन प्रेशर ओनली, एंड इज इक्वल टू delta G is equal to RT ln P2 by P1, right? हमने डिफाइन किया था G is equal to RT ln P, right? For ideal gases. याद है? G equal to RT,
Yes, sir.
RT by RT ln P plus C किया था, right? So if we integrate from P1 to P2, what is delta G for first gas, which is hydrogen, right? Hydrogen. It is going from P1 to P2. So delta G for first gas is RT ln P2 by P1, and similarly same thing for second gas also, it is RT ln P2 by P1, right? ठीक है. RT निकाल दिया हमने कॉमन, और 3 यहाँ 3 क्यों है, एन आना चाहिए एक्चुअली यहाँ पर, इट शुड बी एन, एन नहीं डाला इसने। सो 3 मोल हाइड्रोजन है, तो 3 ln 1.2 p, it is going from 1 pressure 1.0 to 1.2, right? So p2 is 1.2, p1 is 1.0। और ये नाइट्रोजन के लिए 1 मोल है नाइट्रोजन का, and it is going from pressure 3 to 1.2। So in this case for nitrogen it is p1 is 3 and p2 is 1.2। ठीक है, this is going from hydrogen going from 1 bar to 1.2 bar and nitrogen is going from 3 bar to 1.2 bar। इसका 3 मोल्स है हाइड्रोजन का, इसका 1 मोल है नाइट्रोजन का, राइट। सो
वो स्टेप जरा
कौन सा स्टेप?
वो मतलब RTLN P2/P1 के बाद सिंप्लीफाई कैसे किया?
सिंप्लीफाई नहीं किया, सिर्फ सब्स्टिट्यूट किया है। एक्चुअली शुड बी एन यहाँ पर वी आर नॉट चेकिंग मोलर वॉल्यूम, वी आर सेइंग कि कितना मोल्स, मोल्स अलग अलग है, राइट। तो देयर शुड बी एन हियर, एन आर टी एल एन P2/P1। तो आर टी कॉमन आ गया बाहर, और ये हाइड्रोजन के लिए 3 मोल है हाइड्रोजन का, तो 3 into ln, it is going from pressure 1 bar to 1.2 bar, right? So P1 is 1 bar, P2 is 1.2 bar for hydrogen। 3 मोल्स है हाइड्रोजन का, P1 is 1 bar, P2 is 1.2 bar, right? तो ये सब्स्टिट्यूट किया सिर्फ हमने। Similarly, nitrogen is only 1 mole and it's going from 3 bar, P1 is 3 bar and P2 is 1.2 bar, so it is going from 3 bar to 1.2 bar, सब्स्टिट्यूट किया यहाँ पर। समझा गया?
हाँ सर।
Yes, sir.
ओके, तो इसमें एक्चुअली एन मिसिंग है, एन डालना चाहिए। तो व्हाट यू गेट इज -0.38 आर टी। अब बाय सब्स्टिट्यूटिंग कैलकुलेटिंग दिस ln 1.2/3 and ln 1.2/1, you get this in terms of RT, right? The free energy change of mixing for the second step is given by equation 7.121, हमने देखा था, right? It is equal to RT summation of x1 ln xi, right? कल ही किया था। n यहाँ पर डाला है उसने, यहाँ पर नहीं डाला, यहाँ भूल गया वो, right? So delta G of mixing, we are assuming ideal gas, right? So it is summation RT summation xi ln xi। So number of moles, total moles कितना है? 4 moles है यहाँ पर mixing का, RT into, now when we mix 1 mole of hydrogen, 3 moles of hydrogen, 1 mole of nitrogen, what is the mole fraction of hydrogen in the mixture? We're mixing 3 moles of hydrogen and 1 mole of nitrogen. So in the mixture, what is the mole fraction of hydrogen and what is the mole fraction of nitrogen?
0.25 nitrogen,
0.25, and hydrogen is
0.75.
0.75. So that's what he is doing now, substituting xi. So it is, n is total moles is 4 RT into 0.25 ln 0.25 plus 0.75 ln 0.7. So x1 ln x1 plus x2 ln x2. Okay, and that is equal to -2.25 RT. Just calculating these ln values and multiplying by 4. Okay, is this clear? Delta G for pressure change and delta G for mixing. We are doing it in 2 steps. One is saying that we are bringing both the gases to same pressure, and then we are changing, mixing it at constant pressure. Okay, because this was for constant pressure, delta G. Okay, total nothing but sum of this plus this, which is -2.63. If you add these two, R, and substituting for R and temperature, you get -6.52 kilojoules. Okay, any doubts, questions?
Sir,
Sir,
Yeah,
hello.
yes, bolo.
सर जो डेल्टा जी कैलकुलेट किया है ना हमने, उसका
हाँ।
मतलब इंडस्ट्री सिग्निफिकेंस क्या होगा, मतलब क्यों कैलकुलेट करेंगे हम ये?
क्यों कैलकुलेट करेंगे, ये शुरू में बताया था मैंने। व्हाट इज डेल्टा जी?
केमिकल सॉरी, फ्री एनर्जी चेंज।
फ्री एनर्जी चेंज। व्हाट इज फ्री एनर्जी? स्टार्टिंग में बताया था, राइट? वी हैव डिफाइंड ए जी। ए इज व्हाट?
मैक्सिमम वर्क ऑब्टेन्ड,
Yes. And G is what?
नेट यूजफुल वर्क।
Net useful work. So any chemical change which we have, which you are going to see, it could be in terms of reaction, because reaction में change of energy होता है, तभी reaction होता है. And when you have phase equilibrium, when mass transfer takes place from vapor to liquid, or liquid to liquid, or any mass transfer, there's a free energy change, or whatever is available, that is going to lead to a change. Only if there is a delta G, there is going to be a change. If there is no delta G of the process, there is not going to be no change. And we will see how we are going to use delta G. Because ultimately it's an energy, right? For any see, like for pumping of fluids, right? In fluid flow, you need power. You need some energy, right? It could be pneumatic power, it could be electrical power. Similarly, if you are doing some heat transfer, you need some energy. What is the energy in heat transfer? How does heat transfer take place? Because of change in
टेम्परेचर डिफरेंस।
temperature, right? Fluid flow because of pressure. Now we are saying why does chemical what you call transformation take place? Because change in free energy. Because of that only any transformation or phase equilibrium will take place. Otherwise it will not take place. So that is the potential for any chemical transformation. And that's why we are doing all these things.
मतलब यहाँ पे हाइड्रोजन और ऑक्सीजन में कुछ रिएक्शन होगी क्या?
Reaction नहीं, mixing है ना. Mixing is also mass transfer, right? अब मास ट्रांसफर पढ़ रहे हो ना?
हाँ सर।
राइट. उसमें क्या देखते हो आप? डिफ्यूजन, ये वो क्या होता है? व्हाट इज दैट हैपनिंग? दैट्स द ट्रांसफॉर्मेशन, राइट? When one component is transferred from one phase to another phase. So the basis, the root cause of all these things is delta G. Delta G नहीं रहेगा तो होगा ही नहीं वो. Chemical potential, that's why we call it, right? Mu. Potential नहीं रहेगा, potential energy नहीं रहेगा तो कैसे होगा? डेल्टा टी नहीं रहेगा तो हीट ट्रांसफर नहीं होगा. डेल्टा पी नहीं रहेगा तो क्या बोलते हैं, फ्लूइड फ्लो नहीं होगा. सिमिलरली डेल्टा जी नहीं रहेगा तो कुछ नहीं होगा केमिकल पोटेंशियल में. नो मास ट्रांसफर, नो रिएक्शन.
अभी सर यहाँ पे जो नेगेटिव साइन है, मतलब जो पहले था और फिर बाद में कुछ, मतलब उसके कैपेसिटी कम हुआ है क्या, ऐसा होता है क्या?
आपने पहले पढ़ा है, राइट? डेल्टा जी हैज टू बी नेगेटिव फॉर एनी प्रोसेस टू बी feasible. We'll show that later on why it has to be negative. For the time being, assume for any feasible process, spontaneous process, delta G has to be negative. पॉजिटिव रहेगा तो प्रोसेस नहीं होगा. We'll see all those in
ओके
detail.
सर।
Okay? ठीक है. और किसी कोई
सर
क्वेश्चन है? या
सर वो फाइनल प्रेशर 1.2 दोनों के लिए P2 क्यों लिया है, मतलब 1.2?
अरे कैलकुलेट किया ना रे यहाँ पर.
लेकिन सर वो मिक्सचर का है ना.
मिक्सर का है यानी?
मिक्सचर का
हाँ तो
फाइनल
मिक्सर का है
प्रेशर.
ना. हाँ तो दोनों का सेम रहेगा ना. when you are mixing the two things, तो प्रेशर दोनों का सेम रहेगा ना. when I mix nitrogen and oxygen together, एक यूनिफॉर्म सॉल्यूशन हो गया ना. मिक्सचर हो गया ना गैसेस का. तो प्रेशर नाइट्रोजन का भी उतना ही रहेगा, हाइड्रोजन का भी उतना ही रहेगा मिक्सचर में.
पार्शियल नहीं रहेगा क्या, पार्शियल प्रेशर?
अरे पार्शियल प्रेशर नहीं लेने का, हमारे को टोटल प्रेशर लेना है. यू आर गोइंग फ्रॉम वन प्रेशर टू अनदर प्रेशर, राइट? वहाँ पर वो जो इक्वेशन है उसमें जिसमें पार्शियल प्रेशर, टोटल प्रेशर है ये. गोइंग फ्रॉम P1 to P2.
Okay, sir.
We are just saying कि pressure change किया हमने from if you change the pressure of hydrogen from 1 bar to 1.2 bar, what is the change in Gibbs free energy? Mixing बाद में कर रहे हैं यहाँ पर initially we are saying it's a two-step process. Understand this thing. We are not saying कि we are mixing together at the same time. We are just saying that we are changing pressure of hydrogen from 1 bar to 1.2 bar. So what is the change in Gibbs free energy? And then we are saying that we are changing the pressure of nitrogen from 3 bar to 1.2 bar. What is the change in Gibbs free energy? That's what we are calculating in delta G1, first step. Change of pressure only. And then this equation which you derived, delta G2, is for constant pressure processes. Understand the difference? Derive किया था हमने जितना भी किया ना delta G, it was always for constant pressure process, right? So we cannot use this for different pressure processes. That's why we are bringing it to constant pressure 1.2 bar and then mixing it. This is the effect of only mixing at constant pressure. Summation of xi and xi. That is why we are bringing it to first same pressure 1.2 bar and then saying okay, now they are at the same pressure, let us mix them together and see what is the delta G for mixing only at constant pressure.
और सर वहां पे जो डेल्टा जी कैलकुलेट किया वहां पे नेगेटिव साइन नहीं लिया, ऐड किया हमने
टोटल डेल्टा जी है ना, नेगेटिव क्यों लेंगे हम? डेल्टा इट्स अ टू स्टेप प्रोसेस. यू आर सेइंग एक में प्रेशर चेंज किया हमने, दूसरे में हमने मिक्स किया, तो टोटल चेंज करना तो डेल्टा G1 प्लस डेल्टा G2 होगा ना, माइनस क्यों करेंगे?
वो नहीं, ऊपर सर डेल्टा G1 कैलकुलेट करते समय
माइनस क्यों करने का? फॉर्मूला क्या है? RTLN P2 by P1, राइट? माइनस कहाँ आता है?
तो फिर डेल्टा कैसे कैलकुलेट होगा वो नहीं समझा.
इक्वेशन ही वही है ना यार. G is equal to RTLN P plus C. If you integrate D is equal to RTLN P plus C, क्या होगा? D is equal to RTLN P plus C. इंटीग्रेट करो, क्या मिलेगा?
हाँ सर समझा.
That's because you don't go back and read anything at home. We have covered, we have spent so much time in Unit 2 units because this is the foundation for everything which will follow. And if you don't remember what you've done in Unit 1 and Unit 2, you're not going to understand Unit 3. Unit 4 is going to become more and more complex. So my advice to you is go back and read. नोट्स दिए हैं आपको, एक बार पढ़ो जाके, तो आपका दिमाग में वो कॉन्सेप्ट बैठेगा. इट्स कॉन्सेप्चुअल है पूरा थर्मो. इट इज नॉट थ्योरेटिकल दैट ओके आई कैन रीड इट वंस एंड अंडरस्टैंड इट. यहाँ आप समझिएगा, फिर घर जाके नहीं पढ़ोगे तो एक हफ्ते बाद भूल जाओगे. इट विल इवेपोरेट लाइक ऑर्गेनिक केमिस्ट्री. That's my advice to you. Go back and read. At least takes you 15 minutes to read 1 hour lecture notes. Doesn't take more than that. ठीक है?
Yes sir.
There's no harm in asking questions, but I would see if you really want to understand it, you have to go back and read. That's my advice to you. You can ask questions, no problem about that. ठीक है? So this is understood. So if you see delta G1, again here also it is minus. So this is a feasible process. Delta G2, that means pressure change का जो process है, that is also feasible, minus है. Delta G2 mixing also is feasible, it is minus, negative. And we'll see later why delta G negative is important or why it should be negative. In the next unit we'll see that. For the time being, assume that is given, that it has to be negative, and this shows that total process is feasible. Okay? Okay, so let's see, ये हो गया. Then I want to show you something else. Let's see. If I can show you this. can you see this now?
Yes, sir, visible.
Okay, so this is okay. So we have seen example 7.13, 19 and 21. ठीक है? So if you see this thing, this is in SEM 2018 का question paper है. Part A is derive and explain the Lewis Randall rule that you already know. Part B is the compressibility factor is given by the expression z is equal to minus 0.46, 1 minus 0.46, 10 to the power minus 4 चाहिए ये. Mistake है उसमें. For a gas where P is in atmosphere, calculate fugacity at 10 atmospheres. Right? So this is similar to what we had done before, equation example 6.24, and the solution is z is equal to 1 minus 0.46, 10 to the power minus 2p, pressure in atmosphere, calculate fugacity at 10 atmosphere, right? तो ये इक्वेशन लिया हमने. lnf is equal to integral 0 to p z minus 1 by p dp, and if you take z minus 1 by p from this equation above, you get minus 0.46 10 raised to minus 2 p, right? And divide by p and into dp, right? So what we'll get is minus 0.46 10 raised to minus 2 p integral from 0 to p, right? So ये लिया हमने. So what you get is pressure is 10 bar. So what you get is ln f by p is equal to minus 0.046 and f by p is 0.955. So what you get is f is equal to 9.55 atmospheres. Similar problem देखा था हमने, but इसमें सिर्फ numbers different है और कुछ नहीं है. ठीक है?
Yes, sir.
Okay, so let's see next problem. This problem is essentially same thing. Example ने 7.10 कल हमने सॉल्व प्रॉब्लम देखा था, वही है. सॉलिबिलिटी ऑफ ऑक्सीजन इन वाटर निकालने का है, सॉल्व प्रॉब्लम है. This came in 2018. Then this question is from INSEM 2017, example 7.3 of Narayanan. मिथेनॉल वाटर का हमने सॉल्व किया था क्लास में, देखा था. सेम थिंग, exactly सॉल्व प्रॉब्लम. Okay, then this came in INSEM 2017, जो अभी देखा हमने, 3 moles hydrogen 1 mole nitrogen, right? So this is exact same problem, solved problem from Narayanan. So you see many times if you just do solve problems, chances are that you'll get one of them in the exam. And mostly people give from Narayanan. Smith's का भी कभी-कभी आता है, but not so much. Mostly Narayan का देते solved examples because they want a solution, right? Okay. Next problem is in SEM 2016. You have to find fugacity of nitrogen at 1000 bar where pressure and PV by RT or Z is given, right? So what you have to do is find Z minus 1 by P and integrate. So what I have done is, this is the same question. So pressure is given, PV by RT is given. So I calculate Z minus 1 by P for all the values. Then plot Z minus 1 by P versus pressure and find area under the curve between 0 to 1000 bar. जो भी है, जो भी pressure रहेगा, right? So this is the curve. You see Z minus 1 by P versus pressure, and you get a dip like this. नीचे जा रहा है 0 से -3 तक नीचे जा रहा है, फिर ऊपर आ रहा है, and then it goes up. So what we need to find out is we need to find out the net area. So ऊपर का एरिया जो है पॉजिटिव है, नीचे का एरिया नेगेटिव रहेगा। तो दिस एरिया is positive and this area is negative. ठीक है? So what you have to do is you have to take the net area, count the squares which are below the curve for the upper portion which is above 0 and minus the area under the curve here. ठीक है? समझ में आया? So integral is always area under the curve. So if you plot y versus x, area under the curve is the integral of that curve, integral of that equation. So what we have done is I found out this area under the curve, which is positive, and then minus the area under the curve, which is negative. Okay, so area under the curve is 62 squares, and the scale is 10 raised to the power minus 4 because this pressure is z minus 1 by p into 10 raised to the power minus 4, 10 raised to the power of 4. If you see this, and y-axis is z minus 1 by p into 10 raised to the power of 4, and x-axis is one square is or one centimeter is 100. So you'll take the axis, multiply करना पड़ेगा y-axis, x-axis, and that's what I've done here. (62) into x-axis में 1 centimeter है, y-axis में 10 to the power minus 4 है, so it is 0.62. So ln f by p is 0.62. And if you put f by p, find f by p 1.859, and then figure it is 1859 bar. So you get any data versus pressure, Z by RT versus pressure, you can always do that. You can plot the curve data, find the area under the curve and find fugacity. ठीक है? Any questions on this?
सर वो एरिया कैसे कैलकुलेट किया, मतलब जो हमने मेजर किया कि इतने इतने स्क्वायर है, लेकिन कुछ तो हाफ ही स्क्वायर थे, फिर वो एक्सक्लूड किया ना हमने।
हाफ ऐड करने का रहता है। You have to add. एरिया अंडर द कर्व कभी किया नहीं क्या? आप ग्राफिकल इंटीग्रेशन नहीं किया कभी आपने?
हाँ सर वो समझा, लेकिन जो कॉर्नर्स में थोड़ा सा एरिया हम एक्सक्लूड कर रहे हैं ना,
आधा ऐड करने का 1 हो जाता है, 1/4 रहेगा, 3/4 ऐड करने का, यू टेक दैट। इसलिए देखो किसी
वो अज्यूम करने का कि हाफ एरिया है वो।
हाँ, एरिया अंडर द कर्व है ना। सी इफ यू सी दिस एरिया इज से हाफ, this is half area, right? This is half area, this is half area. You have to add all those things. This is like half area और 1/4 area, जो भी रहेगा एस्टिमेट रहेगा ना आपका। You have to add all those things. Similarly यहाँ का भी ऐड करना पड़ेगा, माइनस करना पड़ेगा आपको। This minus, this is positive. You have to take all that into account. If you see, I have numbered only up to 58, right? दिख रहा है आपको 58 तक?
हाँ सर वो दिख रहा है।
हाँ, but if you add the other things which are not counted, it will come to 62. समझा ना? You have to take all those into account. It's not just total squares. It's जितना भी एरिया है अंडर द कर्व, जितना भी है पूरा लेना पड़ेगा। राइट? इसमें एक्चुअली एक मिस्टेक मैंने किया है, माइनस नीचे का माइनस नहीं किया है, नीचे का दिस हैव नॉट डन माइनस, सो दैट हैज टू बी डन। दिस हैज टू बी माइनस, मैंने नहीं किया, बट इट विल चेंज बाय मे बी 62 का 60 हो जाएगा या ऐसा कुछ हो जाएगा, ज़्यादा चेंज नहीं आएगा। but that has to be done.
इंटीग्रेशन यूज करके कैसे एरिया निकालेंगे आप, मतलब कि कैलकुलेट ही करना पड़ेगा मैन्युअली?
डेटा दिया तो कैलकुलेट ही करना पड़ेगा. देयर इज नो एनालिटिकल मेथड बिकॉज यू हैव गिवन डेटा. When you have data, you have to do graphical integration only. When you have equation, you can do analytical integration. That's the rule of integration. You can only integrate equations. You cannot integrate data. यहाँ पर data points दिया आपने, right? What is given is data points. So you have to do a graphical integration only. That's the only way to do it. ठीक है? सेम प्रॉब्लम 800 बार के लिए किया है मैंने, राइट? इफ यू सी दिस same data for 800 bar, I have done it again. If the pressure is 800 bar instead of 1000 bar, if you want to find out 800 bar पर, then you have to integrate till 800 bar, right? यहाँ पर मैंने माइनस किया, if you see this 84 minus 4. Okay, same thing for different pressure. So if we take up to 800 bar, यहाँ पर जो इंटीग्रेशन किया है, this is up to 800 bar. ठीक है? Any doubts? Okay. Next question is again from NSEM 2017. The excess enthalpy of, okay, excess enthalpy हमने नहीं किया है, right? We are not done excess enthalpy, so we'll do it next week. ये problem. Let's see. Yeah. So this problem is from NSEM 2018. Can you see it? Question number 1 is explain how chemical potential can be a criterion for equilibrium. We'll see next week when you see unit 3. Then part B is for binary system show that any thermodynamic solution property is related to its component partial molar properties. M1 bar is equal to M plus X2 dm by dx1 and M2 bar is equal to M minus X1 dm by dx1, where M bar is partial molar property, M is solution property, X1 and X2 are mole fractions of components 1 and 2 respectively. Right? So this is from Smith. This came in NSEM 2017. Right? So we know the definition of partial molar property and how total properties are related to partial molar properties. You see this. M is equal to X1 M1 bar plus X2 M2 bar by definition. Summation of Xi Mi bar. Right? So we can write, or rather, we can say, you can take, if you take total derivative, dm is equal to x1 dm1 bar plus m1 bar dx1 plus x2 dm2 bar plus m2 bar dx2. Right? First component derivative second component derivative first. Right? So we are talking about constant temperature and pressure here. And if you use the Gibbs-Duhem equation, Gibbs-Duhem equation to be used is this one. And we derive the Gibbs-Duhem equations. So x1 dm1 bar plus x2 dm2 bar is equal to 0. And we know that x1 plus x2 equal to 1. Therefore, dx1 is equal to minus dx2. Right? So eliminate dx2 and substitute dx1 in equation B. So eliminate dx2 and combining with equation C, what you'll get is this one. ये आप कर सकते हो घर पे, कैसे होने वाला है आई एम नॉट गोइंग टू शो यू, सिंपल स्टेप्स है, राइट। ये जो है ये टर्म्स के हिसाब से क्या हो जाएगा, x1 dm1 बार प्लस x2 dm2 बार इज इक्वल टू, ये दोनों टर्म कैंसिल हो जाएगा, व्हाट इट इज m1 bar dx1 plus m2 bar dx2, right, and put this one here, so you'll get dm by dx1 is equal to m1 bar minus m2 bar. ठीक है, this is what you get. Okay, so from two equivalent forms of equation A, from limits of x1 and x2, right, if you put x1 is equal to 1 minus x2 or x2 equal to 1 minus x1, what you get is m is equal to, if you put this x1 equal to 1 minus x2, you'll get first equation m1 bar minus x2 into m1 bar minus x2 bar, and if you put x2 equal to 1 minus x1, you'll get this equation. ठीक है, any doubt so far, इक्वेशन डी एंड उसके बाद का इक्वेशन? समझा क्या ये? सिंपल सब्स्टिट्यूशन है और कुछ नहीं है, and in combination with equation D, that means we have to put this m1 bar minus m2 bar here, and we'll get the equation. I'll leave that as an exercise for you to do at home because you're not doing anything at home. सिंपल डेरिवेशन है, स्टेप्स नहीं दिया यहाँ पर, आई एम नॉट गोइंग टू शो यू स्टेप्स, यू डू समथिंग एट होम आल्सो, आई विल शेयर दिस थिंग विथ यू, स्मिथ आपके पास है तो पता है आपको, बट अदरवाइज आई विल शेयर दिस विथ यू. ठीक है, एनी डाउट्स क्वेश्चंस ऑन दिस वन? और ये बहुत बार आता है एग्जाम में, इनसे में बहुत बार आया, फाइनल एग्जाम में बहुत बार आया ये डेरिवेशन, so it is better that you do it yourself at home and understand it. Any questions on this one? सिर्फ बताया मैंने कैसे करने का, वे टू एक्चुअली डू इट. क्या हो गया, चुप्पी हो गई? हेलो, कैन यू हियर मी?
यस सर.
सर
राइट, सिंपल स्टेप्स है बीच के, कुछ में एक्सप्लेन किया उसने ऑलरेडी, he said how to do it and I have shown you exactly how to do it, so you can actually do the derivation at home and see for yourself that you get this equation 11.16. और ये बहुत बार आता है एग्जाम में, so it is better that you do it at home. This is homework assignment for you. ठीक है, डाउट होगा नहीं आता है तो you can ask me on Monday. ठीक है, then we'll see.
Yes, sir.
Okay, so we have seen lot of problems, और इन सब एग्जाम के भी प्रॉब्लम्स देखे हमने, मोस्टली इन सब के देखे हमने. I'll share this thing, keep it PDF with you on the group. Only one example is there which is not covered, which I'll cover after this access properties are defined on Monday. So that will complete unit 2. We'll complete unit 2 on Monday. and then you'll have your test of Unit 2 on next Monday. So go home, read, and do the problems yourself. Just don't see the problems, solve them yourselves by closing the book. Then only you'll get some practice and some confidence that you can solve the problems. Okay? ये है यहाँ पर मैंने दिया है, डेरिवेशन भी है मेरे पास. I have not just shown it, but in my PDF it is there. I'll show you. है क्या नहीं, ये एक्सेस प्रॉपर्टीज का, सॉरी, उसका नहीं है, but it is very simple. Okay. ठीक है, so I'll stop the recording and we'll see you